All right, this is Unit 7, Video 6. These are triangle applications. So we're going to take what we know about the law of sines and cosines, and we're going to apply them to a few just word problems here. So let's get started. I've got two examples for you. You've got the pictures already drawn. You got your note sheet. We're ready to go. So this is example 1 that is found on page 285. Ben Sultanfuss wishes to measure the distance across Big Muddy River. He finds that angle C is 112.90 degrees and that angle A is 31.10 degrees. And he also knows the distance between A and C, which we're calling side B, to be 347.6 feet. If we want to find the distance across the Big Muddy River, we're looking for side A. So I'm looking for side A, but I know I've got angle C here at 112.9. I've got angle A at the top here at 31.10, and I know that this distance right here is 347.6 feet. So if I know all of that information, I first have to decide which of my two laws I'm going to be able to use. This is angle side angle. And we know that for angle side angle, we're going to use the law of sines. Now, since my goal is to find A, I'm going to set that one up first, that I have A over the sine of 31.10, because that's angle A. And this is going to be equal to, well, I know 347.6 feet is B, but I need the sine of angle B, or I need the angle B, and I don't have angle B unless I use our interior angle theorem, so I can go ahead and subtract these values. This doesn't have to be written. This is something you can go ahead and do in your calculator. So if I go ahead and subtract those, 180 minus 112.9 minus 31.1, I get 36 degrees. So that's the measure of angle B. And then we can use that to cross multiply. Go ahead and cross multiply, and again we're going to round here to the nearest hundredths. So the same rounding we've been doing all chapter. Alright, so I came up with the distance we're looking for across the river to be 305.46 feet. Let's go ahead and try the second example. Alright, this one can be found on page 301 of your textbook. It is example 2. A surveyor wishes to find the distance between two accessible points, A and B, on opposite inaccessible points. Okay, so these are points he can't get to from where he's at, on opposite sides of the lake. While standing at point C, the surveyor finds that AC, which is the side over here, measures 259 meters, and that side BC is 243 meters. They also know that the angle ACB, so that's this angle ACB, the vertex is C, is 132.67 degrees. They want us to find the measure of AB. Well, AB is across from C, so I'm going to label this as little c. Now what I've got here is a side angle side, and anytime we had a side angle side situation, we were using the law of cosines. Since I'm looking for little c and I have angle c, that's the one we're going to go ahead and use first. So it's going to be c squared equals a squared plus b squared minus 2ab, those don't need to be in parentheses, times the cosine of angle c. Let's fill in all of our numbers. So to fill in the numbers there, I have c squared equals 243 squared plus 259 squared minus 2 times 243 times 259 times the cosine of 132.67 degrees. Since this is one where I've got the c squared, I can type this into my calculator exactly as we see it. Do not hit enter until you finish, and then take the square root of your answer. go ahead and give yourself a moment to do that. All right, don't forget to take the square root, and when you come up with your answer, the side that the distance that they're looking for between A and B is 459.83 feet. All right, be ready to get to work in class tomorrow.